Hello, everyone. So what I always like to do is just give a little bit of context how I even curated this content, right? So during my journey of just understanding the DevOps world from our customers, oftentimes, as many of you will realize, there's going to be some challenges that are very similar to each other. Now, among some of the questions that you see on the screens right now, what stood out to me the most are the questions where customers ask me, hey, Sam, how can our organization best structure repositories to work better with Terraform? So with that in mind, today I have the privilege of presenting how we can structure repositories for Terraform workspaces to you. Very creative in terms of the title. I know, thank you. My name is Sam. I'm a solution engineer at HashiCorp. And today I'm going to introduce to you the types of repository patterns, its benefits, challenges, and what it will look like in Terraform. Now, I'm going to begin this presentation with some assumptions already made. I'm going to assume that you already know who we are at HashiCorp, whether you are a Terraform user, Vault user, Consul user, or you're about to start on that amazing journey. I'm going to assume that you already know what Terraform is and how to use infrastructure as code, as well as a little bit about our managed service offering, Terraform Cloud. And that's because when we talk about workspaces today, we're really talking about the Terraform Cloud workspaces. All right, with that, let's dive in. So when we're talking about structuring repositories, we're really looking at two types of strategies, a monorepo and a multi-repo approach. Now, if you're using a monorepo, you essentially have a single repository that contains all your application code, infrastructure components, and these are shared across your teams, your products, and your different domains as well. Multi-repo, on the other hand, does quite the opposite. It's going to split your business teams, products, domains into their own respective repositories. But we take it a step further by being able to store reusable resource templates, something that we typically call modules, into their own repositories as well. So we're going to explore both of these patterns, starting first with monorepos. Now, within monorepo, there's going to be two types of approaches. First, you have a single repository, but each workspace is going to be aligned to a repository branch. Now, this is really great for teams that conduct long-running branches in their workflow. The second, however, is a single repository, but this time we have separate directories for each different environment. Each workspace is aligned to their own unique environments and those unique directories as well. Now, this option is also typically applied when there are short-lived branches which are constantly merged into the main branch as part of the workflow. So let's start off first with the single workspace per repository branch approach. Now, this approach, we essentially have our Terraform code combined with a directory that houses all of our modules. And this will be inside a single repository or single code base. To begin creating our own different environments, we're going to be using long-running branches for our dev environments, tests, and prod as well. Now, when connecting the repository to a workspace in Terraform Cloud, you can set different variables for each of those workspaces. That means one set of variables for prod, one for test, and one for dev. Each workspace is going to be listening to a specific branch for change. That means your Terraform plan will only occur when a pull request has been opened or when a push event has occurred on the designated branch. But you might be thinking, hey, Sam, what if we want to promote changes between the different stages? With that said, it's just a simple matter of opening a pull request against the state branch that you want to merge into. So from dev to test, all you need to do is merge those dev changes into your test branch. So let's take a look at what this is going to look like. Our first demo, we're going to explore how those branches in GitHub are used to create individual Terraform Cloud workspaces. We'll then make a commit to the branch to show how we conduct remote operations in Terraform Cloud. And then finally, we're going to merge the dev branch to the test branch to show how the promotion of stages can be conducted. So diving into the demonstration, what you see on the screen right now is my GitHub repo. Inside here, you can see all the different branches that I have. I have my dev, my prod, and my test branches. In order for me to create those unique workspaces, I go into my Terraform Cloud workspace. I can click Create New Workspace, specify my version control workflow, or you can choose the different types of workflows that most suits your organization. But in this case, in this VCS workflow, I choose my GitHub connection. I specify which repository the code sits in. And from there, I go into Advanced option and choose which VCS branch that I want to use. In this case, it could be dev, could be test, or it could even be my prod branch. Now, I've already fast forwarded in time. I've already created 3 of those individual workspaces for me. So instead, let's take a look at what happens when we make a change inside that dev branch. So going back to my GitHub repo, clicking into my variables Terraform code, I'm going to do a quick edit, right? Let me change my instance type to a T2 large. In this case, I'll just type the commit change to be called T2 large. And I have two options here, committing directly to the dev branch, or instead I can create a pull request as well. Now to save a little bit of time, I'm going to commit directly to the dev branch instead, just so we can see what happens when we do that. So inside my workspace, with a quick refresh, you're going to see that once I committed that change, Terraform Cloud automatically runs the planning process for me. It's going to plan the queue, and then it's going to run the planning stage. Now you might be thinking, okay, no, we've seen how that remote operation is going to work. What about if we want to merge dev into tests? Well, going back into my GitHub repo, I can click into my pull request. I can create a new pull request in this stage. And when I do my comparison of changes, I'm going to set my base to my test stage, and I'm going to compare it to my dev branch instead. We can see that the T2 large commit has been available here. So I'm going to create this pull request. And one of the beautiful things about integrating GitHub with Terraform Cloud is that we can automatically run a speculative plan. So that means I can test and see what's going to be provisioned before actually applying it into my environments. Now I'm going to assume that everything's working perfectly here. So I'm going to merge my pull request. And what you see later on is that once I finish merging it, inside my Terraform workspace, with a quick refresh, you'll be able to see that now my test workspace has actually had the plan queued up as well. So this is how we actually trigger those operations when we merge between the different stages. Now, going back into the demonstration of what we've just seen, we were actually able to explore the different monorepo branch approach, how we can actually create the workspace aligning to those individual branches, and what happens when we actually edit those changes inside our branch. When we do it in the dev branch, once we commit it, it actually triggers off operations inside Terraform Cloud. And when we want to merge the dev into test branch, all we needed to do was create a pull request for us to trigger those remote operations as well. Now, the upside to this approach is that we have fewer files to manage, right? Fewer plans that needs to occur. And you can also have better access control for your Terraform Cloud workspaces. The downside, however, to keep in mind, is because we're working uniquely in each stage, there's going to be potential for your branch to drift out of sync. So it's just something to keep in mind. Now, this leads me to the second approach, single workspace per repository directory. Now, essentially what we have in this approach is a single repository, but now we have a directory dedicated to different environments. That means instead of branches, we're going to have subdirectories for dev, for test, and for prod. Now, modules still exist as a separate directory, but all of these are once again located into a single code base or a single repository. Now, with this approach, it aligns really well that with organizations that has different infrastructure resources needed between their environments. And in terms of workspaces, each workspace is going to be configured with a different Terraform working directory. That means in Terraform Cloud, prod workspace is going to be aligned with the prod subdirectory, test workspace, test subdirectory, dev workspace, dev subdirectory. And the Terraform plan is going to occur when the changes are made to the main branch for each of the environment subdirectories. So second demo for the day, we're going to explore how Terraform workspaces are aligned to those environmental subdirectories in the GitHub repo. I'll show you what happens when we make a pull request on the subdirectory to enable those remote operations on Terraform Cloud as well. So moving back into my GitHub, this time we have a separate repo. I call it HashiCorp Terraform demo. We can then see our dev, our prod, and our test environments. Now for me to actually integrate it into my Terraform Cloud workspace, I can click New Workspace. Once again, I'm going to choose the version control workflow, specify my version control provider, and choose which repo that I'm going to be using. The differences, however, is that under my advanced options this time, I'm going to be using Terraform working directory instead. So in this field, I can then specify which subdirectory I want to use, whether it's my test, my dev, or even my prod environment. Now, of course, once again, I've already created that workspace for us. So we're not going to actually dive into the entire process. But instead, what we're going to do is I'm actually going to dive into my dev workspace to conduct some changes for you to see what happens with those remote operations. So going back into my GitHub repo, I select my dev subdirectory. Under variables once again, I'm going to do a quick edit. We're going to change it into T2 large in this case. We'll specify the commit changes, and I'm just going to commit directly to that main branch. Once I do all of this, going back into Terraform Cloud, with a quick refresh in this overview page, you'll be able to see that once again, my plan is going to be queued up and it's going to run through the rest of the workflow for me. So we're going to save a bit of time here. We're not going to dive into and wait for this to finish. Instead, let me walk you through everything that we've just seen, right? So what we've seen before is we've gone through exploring the different monorepo directories, our dev, our prod, and our test environments. We've seen how we can actually create a version control workflow in Terraform Cloud by aligning it to the specific subdirectory inside my repo. And any changes and edits made in each individual directory is going to allow us to conduct those remote operations on Terraform Cloud. Now, the benefits of this model is that it's going to simplify things a lot for us. So all infrastructure state will be hosted in their own directories. Each environment subdirectory has all the resources that they need. So you essentially have a single source of truth for each environment. And you can also apply very simple role-based access control for each of those workspaces as well. Now, the challenge that you're going to have, however, with this approach is that promoting resources across each environment is going to be a bit of a manual process. So that's something to keep in mind. Now, the rest of the time, I'm going to talk about the last pattern, which is about multi-repo. So to transition between a monorepo to a multi-repo approach, the starting point really begins with our modules. So instead of having them housed inside a single repository, we're going to actually remove all of them. And what we'll do is that we're going to have each of those modules have their own repositories for themselves. So in fact, what you see right now is that our network module has its own repo, security, compute each have their own repo as well. But you might be wondering, all right, how can we then allow some sort of self-servicing capabilities for our teams, right? Well, the thing about Terraform Cloud is that with these modules in their own repos, we can actually interface it with our Terraform Cloud private registries. That means our applications can get access to these modules in their private registries through the use of the source argument in the Terraform code. So what you see here highlighted in the red is that the source argument enables us to reference modules stored in the private registries from our Terraform Cloud organization. And this allows us to actually take things a step further because now we can democratize our monorepo even more. Instead of housing all our application and infrastructure resources, we can instead allow each different business teams, applications, domains to have their own repos instead. So on the screen, you have application A sitting in its own repo, but we can also have application B with its own repo as well. And now when we're referencing the different modules, because they each have their own repo, we can enable them to conduct better versioning as well through the use of release tagging. So as you can see, application A, maybe it's an older application in existence, so they might want to have more stable version of the security module. But application B, it could be a newer project that's in place. So we can try and see what the version 3 of the security module would look like for them. Essentially, what this allows you to do is have that layer of more flexibility in the approaches that you want to have for your different projects. Now, the approach for multi-repos works really well for organizations to have large teams. Each team will have the capacity to manage their respective repositories while still sharing those modules in their private registries on Terraform Cloud, allowing different projects to have very different approaches as well. So for the final demo today, I want to walk you through how we can use private registries in Terraform Cloud to enable reusability of the module templates and provide your devs the capability to self-service. I'll be following the HashiCorp Learn Guide for sharing modules in a private registry. So if you want to look it up on Google, you can actually get hands-on and test it out for yourselves. But in this case, what we're showing this demo is how we're going to review the modules we want to use, how we store the module in our private registry, and what that's going to look like when we start doing those remote operations in Terraform Cloud. So let's dive in. This is my GitHub repository housing my Terraform module. Now, one thing to note about modules is that you need to have the format Terraform dash the provider name dash the module name as well. And Terraform Cloud also needs to be semantically versioned. So for the initial publishing, or it should be semantically versioned. For initial publishing, at least one release tag is going to be needed. So in this case, my tag is 1.0.0. And next thing that we want to do is to be able to create a version control connection to our Terraform Cloud organization. So going to my Terraform Cloud, I'm going to select into my registry tab on the left here. Then inside my modules tab, I'm going to click publish module. This will take me through a guided workflow of bringing that module into my private registry. I choose my version control provider, specify which repo that the module is housed in, and I can click publish module. Now, when I click publish module, what actually is published is a whole documentation page that any devs who wants to self-service can actually utilize. This is pulled from GitHub, so we can see what inputs and outputs is going to be provisioned from this module. And what's really helpful here is that the configuration details are automatically generated for me on the right side. So I can actually copy this code and paste it into my Terraform code afterwards as well. So let's see what that looks like, right? What I have here is my learn private module root repository, and I'm going into my main Terraform file. This is where I'm going to put my module block that I've copied from the configuration before. You can see here, my source code has already been generated for me. I can also specify which variables that I want to change as part of the module. And I can also specify which version of this module that I want to use. Once all this is done, I can go back to my Terraform Cloud workspace. I've aligned this with the private module root. So this workspace is connected to that. And then what I need to do is then I can start running an action plan for this workspace. So when I start a new run, this allows me then to start provisioning the resources inside my Terraform code with the source taken from the module private registry. All right, so that's a lot of words that I've just said. So let me just quickly walk you through what we've just seen. So inside this demonstration, we saw how we can actually use modules that we've created and store it directly in our private registries in Terraform Cloud, how we can use the source argument in Terraform provider block to actually reference those modules as part of our Terraform code. And then we can actually apply and provision resources through that way as well. Now, the upside of this multi-repo approach is that modules can be versioned much easier now. Teams have the ability to self-service which sort of modules that they want to use for their workflows. And additionally, because each repo can now be managed by different teams and version, we can limit the amount of blast radius that will have impacted the module if it was breached. And our role-based access control can be applied not just to the teams and repos, but to each individual Terraform workspaces as well. So additional layer of security and governance on top of it. The downside, however, is that because of the use of remote modules, the speed of application through the use of Terraform is really limited by the download speed that you would have for those modules. All right, so I've presented a lot. Let me just quickly summarize everything for all of you today. Now, reviewing everything that we've presented, we have the monorepo patterns that consist of the branching pattern, where each workspace is aligned to a branch environment. The directory pattern, where each workspace is aligned to a subdirectory of the specified environment. And finally, monorepo, on the other hand, has the modules hosted in their own repos, interface with the Terraform Cloud private registry, where we have the ability to have greater control over access and versioning of those modules as well. Now, if you were to ask me what I would recommend, well, to be honest, each pattern has their own unique flavor. That means for your organization, it's really up to you to decide how you want to approach the challenge. If I was to separate it into monorepo and multi-repo, with monorepo, you have a single source of truth for your infrastructure resources. So a single code base for your builds to be optimized because all your resources are in a central location. Teams may have better collaboration as well because they typically follow a single management methodology for each monorepo. Multi-repo, on the other hand, emphasizes more on the ability to provide your teams the way to self-service what they need for their projects with the private registry. So this typically allows faster development and flexibility in the project approach as well, because dev can pick and choose what modules that they're going to need and what version of those modules as well. When it comes to security, multi-repo, because we've essentially democratized it into a modular approach, we can provide better access control by ensuring only the right people with the right permissions get the right access to those modules, repositories, and even workspaces. That's pretty much the end of my presentation. These are some of the references that I used to curate all of it together. Thank you so much for your time.